When you think about the Go programming language, what comes to mind? Probably the big ticket items, right? Go routines, channels, interfaces, those are the superstars. But today we're going to pull back the curtain on a tool that's often overlooked, yet it's woven into the very fabric of idiomatic Go. It's a true unsung hero.
So let me kick things off with a question for you. What do you think is Go's most powerful yet almost invisible tool? It's something you see pretty much every day, but its true power and versatility? That might just surprise you.
Yup, that's it. The underscore, the blank identifier. And trust me, it's not just some placeholder. It's a multi-talented tool that makes our Go code cleaner, our development process way smoother, and our programs a lot more robust.
At its heart, the idea is beautiful in its simplicity. The best way to think about it is like the unix/dev/null file. It's basically a write-only black hole for code. You can assign any value of any type to it, and poof, that value is just gone, harmlessly discarded. But as we're about to see, this simple act of throwing something away is exactly what makes it so incredibly powerful.
So here's our game plan. We're going to look at the 4 secret identities of the blank identifier. We'll start with its role as our everyday assistant, then see how it becomes a developer's best friend. After that, we'll dive into its mastery of some really subtle advanced patterns, and finally, we'll see why it's so much more than just a blank space.
All right, first up, let's talk about the role you see the blank identifier in most often, just being our everyday assistant, helping us deal with values we simply don't need.
Go functions, as you know, love to return multiple values. You've seen it a million times, usually a result and an error. But what happens when you only care about one of those? Well, this is where the blank identifier just shines. It lets you cleanly and clearly discard the value you don't need without having to create some dummy variable that just adds noise to your code.
Okay, now this slide is really important because it shows the difference between a dangerous mistake and a really powerful technique. On the left, you see code that uses the underscore to discard the error. This is a huge no-no. Errors are your friends. Ignoring them is just asking for a crash. But on the right, we see the smart way to use it. Here, we don't need the file info, but we absolutely need to check for an error. By assigning the info to the underscore, we're signaling our intent. I'm ignoring this value on purpose so I can focus on the error. It's clean, it's safe, and it's intentional.
All right, on to its next role. Beyond just being a value discarder, the blank identifier is basically a developer's best friend, especially during that messy, iterative process of actually writing code. Now, anyone who's written Go knows its compiler is, well, it's strict. If you import a package or declare a variable and then don't use it, the compiler just won't build your code. And look, it's not just trying to be difficult. This rule prevents bloated programs and can even help you spot bugs. But when you're in the middle of a thought, it can totally break your flow.
And this is where the underscore comes to the rescue as a temporary fix. That compiler error pops up, unused variable. Unused import, you can just assign it to the underscore. This tells the compiler, hey, chill out, I know it's unused for now, and it silences the error. This lets you compile and test your work without having to delete code that you know you're going to need in 5 minutes. It's just a simple trick to keep you in the zone.
Okay, so we've seen the day-to-day uses. Now let's get into the really clever stuff. The subtle, advanced patterns where the blank identifier reveals a much deeper layer of Go's design philosophy.
Now this is a fascinating idea. Sometimes you need to import a package not because you want to call its functions, but simply to make it, well, exist in your program. See, many packages have a special init function that runs the moment they're loaded. This function can do all sorts of setup in the background, like registering database drivers or setting up HTTP handlers.
So the question is, how do you tell the compiler, hey, I need this package for its side effects, but I'm not actually going to call it by name? You use this exact syntax. I know, at first glance it looks a little weird, right? An import statement with an underscore just sitting out front.
So here's the magic behind it. By putting that underscore in front of the import path, you're sending a clear message to the compiler. Please link this package and run its init function, but I promise I won't be referring to it by its name. The compiler sees the underscore and says, okay, got it, and considers the package used. This is how packages like perfob can automatically register powerful debugging tools just by being imported. It's an incredibly elegant solution.
And now for our final advanced pattern. And honestly, this one's a thing of beauty. We can actually use the blank identifier to enforce contracts between our types and our interfaces all at compile time. So, in Go, a type satisfies an interface implicitly, just by having the right methods. Normally, the compiler checks this for you when you try to use a type where an interface is expected. But what if nowhere in your package do you actually make that specific assignment?
You could change a method on your type, accidentally break the contract with the interface, and you might not find out until much, much later.
This single line of code is your safeguard. It might look like a regular variable declaration, but its real purpose is to send a message directly to the compiler.
Okay, let's break this down because it's so clever. This code tries to assign a nil pointer of type *raw message to a variable of the JSON.marshaller interface type. This forces the compiler to ask itself, wait a minute, does *raw message actually implement the marshaller interface? If the answer is no, if you forgot a method or got the signature wrong, the program will not compile, period. And because we assign it all to the blank identifier, no actual variable gets created at runtime. It's a pure, zero-cost assertion that your code is correct before you even run it. Genius.
So we've been on quite a journey with our humble little underscore, haven't we? Let's pull everything together and recap what we've discovered.
The blank identifier really does wear a lot of hats. It's a discarder for values we don't need. It's a silencer for those pesky compiler errors during development. It's an enabler, activating powerful package side effects. And it's a type checker, guaranteeing our code is correct at compile time. 4 completely distinct jobs, all from one simple piece of syntax.
And that's really the big takeaway here. The blank identifier is a perfect example of Go's entire design philosophy in action. It shows how a seemingly minor feature can have a huge, profound impact, leading to cleaner code, a less frustrating development experience, and ultimately more robust and reliable software.
So I'll leave you with a question to chew on. What other simple features in Go, or in any language you use, have this kind of hidden depth? Because it's often in these tiny little details that you find the real genius behind a tool's design. Thanks for tuning in.